I guess the way we design the environment and the surfaces we choose has such a big impact on the heat of the environment we live in, and also the way that environment retains heat. Built surfaces such as this can retain heat exceptionally well. And when we look at a surface like this car park, we're currently sitting around 63.8 degrees Celsius as a surface temperature. When we look at the shade, that's actually reading at 36.8 degrees. I'm standing within the same spot, but we have a tree canopy on one side, we have unshaded asphalt on the other. And I guess it's that kind of difference in surfaces and surface that leads to the surface temperature differences. All right, so here we are in a lovely, cool urban environment. We have a wetland behind us, so the air's being naturally cooled from that water. But looking at here, this area, we've just irrigated some of this turf. We're looking at around 19 degrees for some of these areas in a little bit of sun. If we go back here, fully under the tree canopy, we're looking at temperatures of around 16 degrees Celsius. Some of this irrigated mulch is actually down to around 14 degrees. So that mulch is actually holding water. And that's, again, it's another surface that's going to hold water and gradually release it, which will cool the environment around it. If I just move over to the sun a little more, so some of that unirrigated mulch that's been in full sun is around 43 to 44 degrees. So that's the temperature increase for around 30 degrees Celsius within about 2 metres. All right, here we are out in an open car park with very little shade, and we're looking at a surface temperature on this car park bitumen of 64.2 degrees. Now I can look at this London play train behind me and quickly get a reading under the canopy of 21 degrees. It's almost a 40 degree surface temperature difference. That is where our urban heat is coming from.